what can be divided into this part and this part. Okay. Well, this doesn't have any b's in it, so 3 is in this. I can divide a 3 to that. I can divide a 3 to that. So I will divide it. You don't take it out, you divide it. You divide 3 to that, it leaves you 2b squared. You divide 3 to that, and it goes 1 time. Too often, in more complicated problems, people will forget to put that 1 down. You're dividing out, you're dividing out, you're dividing out. So that means when I multiply back in with the distributive property, I better get what I had to start with. So I must have a 1 there. And what I want to say to you about factoring is you shouldn't have to have the back of the book for answers. All you have to do is multiply back together what you think your answer is and see if it's the original problem. In other words, factoring 6, or let's say factoring 8, can be factored as 4 and 2. Why? Because 4 times 2 is equal to 8. So you should be able to check your answers by simply multiplying back together to know if you have it done correctly. So first thing, always look for a common factor. So let's look at example 2. All right, what will go into the numbers? Well, 5 will divide into everything, so we'll take a 5 out. And then M. Now this is 4 M's, M times M times M times M. This is 7 of them, and this is 9. So the smallest number's the only thing we can divide out. So we'll divide out that. Now, dividing 5 into that, we get 8. And dividing this into that, we get 1. So that's 8. Dividing 5 into 20, we get 4. And dividing M to the 4th into M7 is M3. Remember, when you divide, base is the same, you subtract powers. You subtract powers. All right, well, 5 will go into 5 1 time, and M will go here 5 power of M. Now let's check it out. We multiply it back together. This times that, sure enough, checks. This times that, checks. This times that, checks. So we did it correct. Common factor, common factor, common factor. Don't forget that when you start every problem. Look for a common factor. All right, now let's go to the same type of thing, but it always throws a lot of students. What you need to do when you get into this level of algebra, you need to be able to look at a parenthesis as a single object. In other words, if I had 3ax plus 7x, what is a common factor? X. I could take the x out and have 3a plus 7. Well, you need to think of that as just like an x, a single object. So what we can do is we can say this is a common object that's in both of these. So I will take that out, and that will leave me. Dividing that into that leaves me 3a, and dividing this into this goes 7 times. Okay. You need to look at, if you have a parenthesis, it's exactly the same parenthesis, you need to look at that as a single object. I'm just going to take that out. Well, if I divide it out, it leaves me that. If I divide it in here, it gives me that. This one is where you have 4 terms. A lot of times a problem like this will start out as 3am minus 3ap plus 7m plus, or minus 7p. Okay, you have that problem to start with, and what you'll do is factor out of 7 and get that, and factor out of 3a and get that, and then continue to factoring. Okay. All right, let's go now to the rest of the examples. Now all the rest of the examples, well, all but one, all the rest of the examples, is to learn how to factor trinomials by the FOIL method. So here we go. Example 4. Put down 2 parentheses. Factors of this, x and x. Factors of this, 7 and 1. And then this added to this must add up to the middle term. And it does. If I put a plus there and a plus there, that's a plus 1x, plus 7x, checks. Okay? So look at the FOIL method. First times the first, yes. Last times the last, yes. Inside plus outside, yes. Checks. Okay. All right, let's go to example 5. All right, so I'll look. Common factor? No. Parentheses. Okay. Factors here, x and x. First times the first, yeah. Last times the last. Now, watch this. Last factors of this would be 5 and 2. Okay. This times that. Now, 2 times the 5 is going to give us 10. We want a minus 10. So that means this could be the minus and this could be the plus. But watch what happens. The inside added to the outside would be a positive 2x and a minus 5x, and that would give us that. Therefore, we go change the sign and make it a minus 2 and a plus 5. Now when we check it, we get a minus 2x and a plus 5x, which adds up, and we did it right. It is a trial and error. You don't have to see it right off to start with. All you have to do is put down what gives you the first term and put down numbers that give you the last term. And then this added to this multiplication must be the middle term. You see, the factors could have been 10 and 1. Could have put a 10 and a 1, but that's not going to give me a 3. Put the 10 over here and 1 over here, it's not going to give me a 3. So it's just a trial and error of the factors. So the factors of 10 are 10 and 1 and 5 and 2. Well, one thing to start with on problems that don't have a number out here, okay, what you can do is look, well, 10 and 1 will give me 3, but 5 and 2 will give me a 3, so I'll use these. All right? Just trial and error. Don't expect to have to see it the very first thing. All right, so let's go to number 6 and show what I'm talking about. We're going to show back to our first rule. Before you start the parentheses here, always look for a common factor. So here's a common factor of 2. So we'll factor that out. And now we try to factor this. Okay? So x and x, first times the first, works, and 1. And what happens, there is no way that that can add up to a minus 7. So therefore, we are through factoring. And that's the answer. Okay? So you're going to have some problems in textbook and probably on exams where this cannot be factored. But you don't know until you sit and do trial and error. All right, so don't forget common factor first before you start the FOIL method or factoring of any kind. All right, let's now look at example 7. And we want to look at factoring by the FOIL method. Now, we've got lots of choices here. Factors of 48 would be 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So let's just put some of those down and see what happens, all right? So if I put 16 and 3, well, that is 3 and 16, and that's not going to give us 2. So therefore we know that shouldn't be the answer. So back up here, these choices would be 8 and 6, because there's a difference there of 2. So now we're not there yet though, because here's the thing I want you to hear. If the last sign is a minus, then this has to be a minus and a plus. Or the minus could be over here and the plus over here. I'm not saying which one, but if the last term is a minus, then it's going to be a plus minus. Now what we do is simply figure out this plus this. Well, this is a minus 6x and a plus 8. That doesn't work. So what I'll do is switch and make this the minus and this the plus, and then it works. Again and again, trial and error. Okay, trial and error. But don't forget this last number, you got a bunch of choices. And sometimes if you put a number here, it'll change these numbers, okay? So watch out for that. All right, number 8. Okay, number 8, we now have a number in front of the x squared. So this will then be 2x and x. Now the factors of 15 are 1 and 15 and 3 and 5. So I'm going to do it wrong a few times just to see all the possible things that can happen. All right? So let's put the 5 here and the 3 there. All right. Now, whoops. If this is a minus, one of these is going to be a minus, one is going to be a plus. Now, this is a minus 5 and a plus 6. Does that add up to plus? No. So what I'll do is I'll switch places with my 3 and 5. Now, this is 10x and a minus 3x. Does that work? Yeah, that's it. So we did it. Okay. Just trial and error. Now with practice, or some people can just see it all to start with. With practice, some people can just write that down to start with. Don't worry about that. You just learn how it works. Okay. If you're going to stay in algebra, you're going to get more complicated problems with letters and everything. And the way you know where this works or not is simply multiply it back together. First times the first. Last times the last, inside plus outside. Okay, let's go to example 9. All right, here we go. Well, first factor is 6 and 1. Last factor is 5p and p. Now, first times the first, yes. Last times, well, wait. Now, if the last term is a plus, then these signs have to be the same. These signs have to be the same. If the last sign is a plus, then these have to be the same, and they have to be whatever that middle one is. So if the last one's a minus, it's plus minus. But if the last one is plus, then it's either going to be 2 minuses or 2 pluses, and that'll tell you which one. All right, now let's check. That's a minus xp and a minus 30. That doesn't work. So let's move the 5 over here. All right, so that would be 5px and 6. That doesn't work. So what that means now is let's go back and change the 6. And let me erase this where it's a little better. It doesn't look so messy. So what we'll do then is on the 6, we'll make it 3 and 2. Now let's go back with our 5s, okay? So we'll go put 5p here and P there. And look what happens. First times the first, yeah. Last, yes. Minus 2 and a minus 15, and it checks. And that's what I'm talking about. You just trial and error. When you have a bunch of choices, you have numbers here and here, you have to trial and error to find out which combination works. But there's no problem to it. Write them down and simply go back through the FOIL. First times the first, last times the last, inside plus outside. Trial and error. Practice, practice, practice your homework. Okay, let's look at number 10. Now, 10 and 11 is going back to this thing I referred to in example 3. If you have 4 terms at this level of algebra, what you do is look for grouping. You look for a common factor in the first 2, which in this case would be 3x, and a common factor in the last 2, which would be 2. That's a plus, okay, plus 2. And now we're back to example 3, which says this is a common factor. So I'll take that a plus b out, and that leaves me 3x plus 2. Now let's see if it works. First times the first, 3ax. Last times the last, 2b. Inside, 3bx. Outside, 2a. Works. Okay. You can always check your work in factoring by multiplying it back together. All right, let's look at example 11. Okay, we have 4 terms. So what we do is look for a common factor. And that would be 3a squared plus 1. And a common factor, which would be a minus 6, and that would be 3a squared plus 1. Factor out a minus, check it out. Minus times a minus, a plus is a minus. Minus, so it checks. Now we have a common factor. This is the same, so we'll factor it out. Leaves us a to the 4th minus 6. Okay, so if you have 4 terms, look for common factor of the first 2, common factor of the last 2, and then that then will be a common factor. That's what's left. Now in some college algebra classes and further, sometimes you group the first 3 or the last 3 and then it factors that way. So it's not always this way, but this is the way your textbook will be for intermediate algebra. Okay, let's go to number 12. Okay, first thing is common factor. Common factor has 3. See, 3 will go in everything. And x to the lowest power. So 3 will divide in 3 one time, and x will divide in that x squared. 3 will go into 30 10 times, and x to the 4th into that will be x. And 3 will go into 75 25 times, and x to the 4th and x to the 4th is 1. Okay. Then we check it out. Yep. All right, now we're not through. Don't forget, after you take common factors out, keep looking for factoring. So let's factor this x, and 5 and 5. If the last term is a positive, then these signs are the same, and they're whatever that sign is. All right, that I hope will give sufficient examples of being able to factor common factors, FOIL method, and when you have 4 terms, the concept of grouping, and then common factor. All right, let's continue on with some more examples of factoring. All right, we're looking at the second part of tape 39. Just a bunch more examples and a few more difficult ones. So let's look at it. The number 1 of part 2 is x squared minus 9. Right? So we look for common factor. No. Then we look for the FOIL method. So we put x, and 3, and 3. Now remember, if the last term, this is the last term, is a minus, then it's a plus minus. Plus here, minus over, it doesn't make a difference where. Now check it out. First times the first, yeah. Last times the last, yes. Inside, drops out, yes. So if you have a no middle term here, no x, and you have a minus, then it's simply the perfect squares. Okay. But just FOIL method, it'll work. All right, number 2, 4 terms again. So we're going to look for a common factor. Common factor. And look what happens. We have a common factor here. Okay. Then check to see if it can be factored in further. No. This is not a perfect square. It needs to be a 1, 4, 9, 16, 25. So, all right. Number 3, example number 3. What's our first rule? Common factor. So factor the common factor out. And now we're back to problem number 1. This factors into plus 3 and minus 3. Okay. All right, let's go to example 4. Now, example 4 is a special case, just to memorize, not any kind of thinking or reasoning it out, just memorize it. If this is a cube, and this is a cube, in other words, something multiplied 3 times, then it's the first, last, first squared, first times the last squared, and opposite sign, whatever this is. This is the same sign, and this will be opposite. So therefore, the answer is x plus 2. In other words, the cube root of this and the cube root of this. And then you don't look at anything except right here. So it's the first one squared. It's the first times the last, opposite sign, and it's the last one squared. Just memorize it. Don't try to think it out, FOIL method or anything else. Just memorize that it's the cube root of this, cube root of this, and when you write that down, then you just go to this memorization. First one squared, last one squared, this times that, opposite sign. All right, we'll do another one of those a little later. Number 5. Common factor? No. Therefore, we look for FOIL method. X and X. Okay. And 4 and 3. Does 3 and 4 give us 4? No. So let's try 6 and 2. Well, 2 and 6, yes. Now we got to figure out, if the last one is a minus, then it's minus plus. And that checks. It's a minus 6 and a plus 2 is a minus 4. All right, now let's look at number 6. What number 6 is trying to say is that's a perfect square, and that's a perfect square, but that's not a minus, so it doesn't factor. That's it. Just leave it alone. No common factor, will not factor in 2 parentheses. That must be a minus for it to have a chance of factoring in 2 parentheses. All right, so let's look at number 7. And here we now have perfect square, and a minus sign. So therefore, it's x squared, and 4 and 4. But don't forget, always see if you can factor some more when you get through with the problem. Check each one of these out. Perfect square, yes. Perfect square, yes. Plus, nope. That can't be factored anymore. We'll just copy it down. Perfect squared, yes. Perfect squared, yes. Minus, yes. So that can be factored in to x and 2 and 2. So now, hey, don't forget to write this one down. If you come down here and just write these two down, your answer is wrong. Keep that one down, even though you can't, because now if you multiply all that back together, you will get what you had in the original problem. Okay, so I'm hoping you're listening to these statements and stuff. In other words, look for common factor. Once you factor it one time, look to see if it can be factored again. All right, let's go to example 8. And it looks just like complication, but it's still the same process. Common factor. What divides into 20 and 60 and 45? Well, I guess 5 would do it. So we'll divide a 5 out. And x4, x3, x2, so we'll take out an x squared. Y, no y, so we can't take out a y because there's not one here. So I guess we're through. All right, now then, watch this. This divided in that. If I come up here and divide 5x squared in that, that gives me 4x squared. Now write it down in your, when you're writing, write that down right there. Okay. So 60 divided by 5 is a minus 12. X cubed divided by x squared is that. And then the y is left. Come along and put the 5x squared. 45 divided by 5 would be 9. X squares drop out. You get y squared. So we did a common factor. Now what did I say a while ago? Look to see if you can factor it some more. So 5x squared, FOIL method. So we'll put 2x and 2x and 3y and 3y. Now if the last term is a plus, then the signs have to be the same. And then check to see, and it does. That gives us a minus 6xy and a minus 6xy, so it checks. Now look to see if this can be factored. No, no, so we're now through. All right, so again, listen to the process and don't be just looking at these examples. Listen to the process. All right, number 9. 4 terms. So what we're going to do is look for a common factor. Look for common factor. Common factor here is 3p. Dividing that out, divide 3p out of that, leaves us a. Divide 3p out of that, leaves us b. Now, what a common factor back here is, you know, there's not one, so you can just put it in parentheses. I mean, you can say it's 1. There's a common factor 1, but still, if you just have that, put it in parentheses, because look what we have now. So, we have the common factor, parentheses, and it leaves us 3a plus 1. Now here's the reason why I try to get students to do this division. Go ahead and divide this by a minus b, drops out. Divide by a minus b is a 1. Okay, so you get a 1 back there. All right. All right, so be aware of that. All right, number 10. Number 10, what do we have here? All right. We have a cube. We have a third power, a 3 or 6 or 9 power. So what we're going to do is look for that special case, all right? So the cube root of this would be 3a, and the cube root of this would be 5b, minus, same sign. Now, all the problems you're going to run across in your textbook, it's going, when you look at that and try to figure out what the cube is, it's either just try 2, then try 3, and then try 5, and that's pretty well going to be maybe a 7, 6 or a 7 would be the highest you're going to get. Just figure it out. All right, what's the rule? It's the first one squared, so that's 9a squared. It's the first times the last, so that's 15a times b. Opposite sign, and it's the last squared. So it's 25b squared. Okay, just memorize it. Okay, here we go with the last one. Now, I'm going to put something down here, then I'm going to erase it before we do the correct. If I gave you x squared minus y squared, then it would be x minus y and x plus y. If I have some object squared, and if I have some object squared, then it's this object, and it's this object. Okay? So let's show you how easy this is if you'll think of the parentheses as an object. All right? So it's A minus the parentheses, and it's A plus the parentheses. Just think of that as an object. So it's A, and then it's this parenthesis, parenthesis. That's a minus, so it's plus, minus. Now, in the back of the book, they're going to remove the inside parentheses, and that's the way it's going to look. But think of a parenthesis as a single object right here. So it's A minus that and A plus that. All right, this concludes tape 39 on factoring.